Good morning everyone. I am Bharathasan from Mechanical A GCT Coimbatore. Today I am going to discuss about the topic CAM design and practical consideration. So let's get into the topic. The fundamental law of CAM design is any CAM designed for operation at other than very low speeds must be designed with the following constraints. The CAM function must be continuous through the first and second derivatives of displacement across the entire interval 360 degree. Corollary: the jerk must be finite across the entire interval, that is 360 degree. Next, CAM terminology. The following are the most important terms which required in designing a CAM model. They are the types of follower motion, they are of rotation and translation motion, the types of joint closure, force and form joint closures, types of followers, they are roller, mushroom and flat followers, the direction of follower motions of two types, they are radial and axial follower motions. The types of motion constraints are critical extreme position (CEP) and critical path motion (CPM). The types of motion programs are of RF rise and fall, RFD rise, fall and dwell, RDFD rise, dwell, fall, dwell. As we seen before, the types of follower motion are of two types: oscillating follower and translating follower. Here we can see that the oscillating follower's cam is in the shape of circular and small is a combination of a small radius and a large radius circle, and translating follower is of a single circular ovulatory disc shape. Types of joint closure, they are of two types: force closed cams. In force closed cams, it requires an external force to keep the cam in contact with the follower. A spring usually provides with force. Next, the form closed cams. The form closed cams are closed by joint geometry and they are slot milled out of the cam. With this diagram, we can see that in the force closed cams, the follower is over the cam, which moves in the path of the cam. In form closed cams, like the follower is placed in between the cam. That is here the white path. Here we can see the follower will move along with this path. The types of followers: roller followers. Roller follower is a follower in which the follower will be in a roller motion like this circular diagram. Next, the mushroom follower. It will look like a mushroom in the shape that travels on the path of the cam. Next, flat faced follower. In which the follower will be in a flat face that moves along the outer path of the cam. Types of motion constraints. These are also take place a very good important in the designing of cam. They are critical extreme positions (CEP). Start, that is start and end positions are specified but not the path in between. Next, the critical path motion (CPM). Path at derivative is defined overall or the part of the cam. Types of motion program. And this also we have seen before, that is from the CEP cam profile. Dwell. It means nothing. Dwell is nothing but the period with no output motion with input motion. Next, rise and fall. No dwell. Next, rise, fall, dwell, RFD, one dwell. Next, rise, dwell, fall, dwell, RDFD, two dwells. SVAJ diagrams. SVAJ diagram is nothing but that every cam design will have an SVAJ diagram. This is nothing but the position, V is the velocity of the cam, A is the acceleration of the cam, and the J is the jerk of the cam versus the cam angle. Table for peak VAG, that is velocity, acceleration and jerk for cam functions. By using this table, we can calculate or take the required fixed or standard values to design a cam. It consists of types of function: constant acceleration, harmonic displacement, trapezoid acceleration, modified trapezoid acceleration, modified sine acceleration, 3, 4, 5 polynomial displacement, cycloid displacement, 4, 5, 6, 7 polynomial displacement. and maximum velocity, acceleration and jerk. And these are the functions of this for this Q1 specifications. CAN manufacturing considerations. And in order to design a CAM, the following are required in consideration. That is, medium to high carbon steels or cast ductile iron. The material should be in this type. Next, the CAM should be made in the process or milled or grounded. Next, heat treatment for hardness should be made. CNC machines often use linear interpolation. Actualizes theoretical CAM performance. Larger acceleration due to manufacturing errors and vibrations from jerk. The CAM design that we made in the designed in the software will be give a result which will give a required amount of acceleration, but when that comes into practical, it will gives a larger acceleration due to manufacturing defects and some vibrations from the jerk. And these are the resulting graphs of some of the types. Modified trapezoidal fall acceleration. Next, modified sine fall acceleration, cycloid rise acceleration, 4561 polynomial rise acceleration. By comparing this, we can imagine the path of the movement of the CAM. Next, the practical design considerations. Before designing a CAM, we should check. This will look like a checklist for the designing a CAM. They are transiting or oscillating follower, force or form closed follower, jump versus crossover shock, radial or axial cam, roller or flat rest follower or mushroom follower, to dwell or not to dwell, to grind or not to grind, to lubricate or not to lubricate. So that's all, my friends. Thanks for giving this wonderful opportunity. Thank you, everyone.